lecture, we continuously talk about FM signal. Generally, it will be wideband FM. Last week, we talked about narrowband. Tuesday's lecture, we talk about wideband. We quickly review what we have learned last time. For beta is no longer a small number, less than 42. We can write our those two simplifications, right? In terms of only the summation of Bessel function. So combine everything together. If the message is a sinusoid, we have this part. So wideband FM can be considered as many sideband or many harmonic summation. Each harmonic's amplitude is related with your which sideband, right? How far from your carrier and what the index you choose for this modulation. So this is wideband FM in equation. Okay, so basic function can be obtained from either curves, right, or from table. We also show this example. When you have different beta, bandwidth is different. Power for each harmonic is also different. So last time we showed two examples. How can we calculate power of each sideband? Okay, total power is A over A squared, half A squared, and for each sideband, A is half A squared, J n beta squared. N is which sideband beta is the index we choose. So carrier N we use 0, right? First sideband we use 1 minus 1. Second sideband we have 2 minus 2. And we show two examples, right? One is graphics showing what's going on about the power from this sideband. So they're changing when you have the given beta value. Okay, this one is from our textbook. We calculate. So based on the problem, we find beta, right? Then we find carrier power, remaining power, and power from second sideband. Here today, the new stuff that we talk about. Bandwidth. So we know bandwidth is also changing when beta is different. The most accurate way we should use significant sideband. However, not so straightforward. So we have three different equations. Last time we talked about we have three sets of equations: small beta, large beta, and beta in between. If you are not sure, you use Carson's rule. For beta, small number, right? This one is like a hard line there, a threshold, less than 0.2 narrowband. Large number, use this one. In between, we use Carson's rule. If you are not sure it's large or not large enough, you can choose Carson's rule. So let's look at one example. Okay. Let's look at this one together. 10 micros carrier is frequency modulated by a sinusoid signal. So my carrier is 10 micros, right? 10 micros. My message is sinusoid. The peak phase deviation is 50 kilohertz. Calculate the bandwidth of FM signal. The frequency of sinusoid signal is 500K, 510 hertz. go through this example together. My carrier frequency is 10 megahertz. However, it will not play any role in my bandwidth. This one will be my baseline and my carrier. So what else we know? We know peak frequency deviation is 50 kilohertz. Then we want to find my bandwidth for different three conditions. Okay, we know we should use the equation that I just showed in previous slide. So which one we should choose, depending on how big, right, or how small is your beta. So we always have to find what is beta. So step one, always find beta. Half. Okay, beta is peak frequency deviation divided by your signal's bandwidth. So delta F over Fm, or delta omega over omega m. Delta F is given, right? 50K. 50K. My signal's frequency Fm, number one, is 500K, right? So 500K. 0.1. I know my beta is 0.1, so we use 4 set, right? It's a narrow band. We have narrow band FM for sure. My bandwidth will be 2 times of my signal's frequency. So here, 2 times 500K. 1 megahertz is my bandwidth. So the bandwidth is only related with your signal's bandwidth, right? Signal's bandwidth for narrowband FM. So this is part A. It's part A.
So, what is the 0.1 that we calculated?
Yeah, 0.1 is modulation index beta.
Oh, okay.
Yeah. So beta is delta F over Fm.
But we don't use that with the bandwidth calculation.
This one, no, but later we use.
Oh, okay.
Yeah.
Oh, I see.
Yeah. Okay. So beta actually has, we can call it has 2 rows. One it can tell us which equation which we use. Second, it can also be used to calculate your bandwidth for large beta and Carson's rule. Okay, so number 2, right? Now my FM is 500. So here, still beta delta F over Fm. 50 over 500. Okay, 100, right? So this one is, obviously, it's a large beta. So my bandwidth will be 2 times of delta F or 2 beta Fm. So you can use beta here, right? You can use your beta here. Delta F is 50, so we get 100 kilohertz. My bandwidth is much wider compared with my signal's frequency, right? So we call it wide band FM, wide band FM.
So because it was a large beta, you used it in the bandwidth equation?
Yeah, large beta we use 2 times of delta F, right? Oh, yeah. So large beta we use B equal 2 delta F. Yeah, delta F is 50, right? So is 100. So here, okay, any problems, questions? So the last one, you can imagine, right? We are going to practice by using Carson's rule. So the last one should be C. Beta will be ZF over FM, 50 K over 10K, 5. Beta is 5. So when beta is 5, definitely it's not narrowband, and it is not so large, right, as this part. So we use Carson's rule. Okay, so it will be 120 kilohertz is for the last part. We use Carson's rule. C can also be written as 2 times beta plus 1 FM. 2, 4 plus 1 times 2 is still 120 kilohertz. So in your final exam, definitely I'm going to ask you calculate a given FM signal's bandwidth. Step 1 always be check your beta, right? It's wide or narrow. So step 1, step 2. Beta is delta F over Fm, delta omega over omega m. Bandwidth, which I choose, right? Narrow band, wide band, or Carson, depending on the value of beta. Okay, any questions for this one? Okay, so here, right? We have narrow band FM, beta 0.1. Wide band FM, large beta, the bandwidth is 2 times of my peak frequency deviation. When beta is 5, we use Carson's rule, so we get 120 kilohertz. So narrow band, wide band is how wide or how narrow compared with your signal, right? Your modulating signal. Your missing, right? 1 megahertz is much wider than 100K, right? But your original signal, for part A, original signal is 500K, right? Here, original signal is 500 hertz. So wide or narrow, related how wide, how narrow related with your message. So actually, I want your opinion. Chapter 6 will be the last one include in our final exam. We are going to talk about chapter 7, but not required for your final exam. So this one, do you want homework? Oh, okay. So previously I gave some problems to practice, but we don't collect them and grade them. We can give you some homework to practice problem to practice, and I can pose a solution. So it's up to you. If you really want another homework, we can do that. If you prefer just practice and don't return in your homework, we can also do the practice and solution. not towards the end of the semester, right? You have many other things, right? You have review, right? You report, right? Other things. So it's up to you.
Extra credit or something?
Oh, okay. Sure. Yeah, we can have extra. Yeah. Yeah. So so one. Can I proceed? Okay. So yeah. First, I'm going to give you the assignment for chapter 6. If you hand in, you are going to get extra credit. But still depending on right how good you finish your homework, right? Okay. Yeah. And I'm going to post solution. Yeah, maybe 1 week, right? 1 week after the. Yeah, so 1 week after the day, after the day. Okay. So any problem for this one? How can we find bandwidth? Always find beta first, right? Then you have 3 different equations to choose with 3, right? So we spend most of our time talking about Fn. We also want to talk about a little bit what is phase modulation. Okay, just recall, right? Phase. For phase modulation, my phase is proportional to input signal's amplitude. Fm, frequency is proportional to the input. So phase is proportional to the integral, right, of your input, right? We talk about this one, just recall. We want to talk about a little bit what is phase modulation. Phase modulation is not required in our quiz homework and exam. So still, if we have a sinusoid signal as my input, as my message, okay, have FM signal, right? FM signal, we know frequency is proportional to my input, my message. Third omega we call P, frequency deviation, how far I can oscillate, right, from this baseline. For PM, my phase is proportional to my message, and here, third theta we call P, phase deviation, so how far I can away from my baseline phase. This is the initial phase, right? Initial phase. So this is for PM. Yeah. So from previous slide. This is my phase, right? This is my phase. Derivative of it will be my instantaneous frequency, so we get omega c, right? Omega c. Derivative of cosine, we get minus sine. Theta 0 is a constant, so this one derivative is got. There's no initial phase left compared to the derivative. Okay, here we still have a third omega, right? This one we also call peak frequency deviation. How far you are going to away from omega c? But this one is a little different from previous omega c we mentioned, or third omega we mentioned from FM signal. So for FM, third omega is A from your message, right? Kf, this is the constant. Previous slide we talked about Kf, constant, linear proportion to function your incident frequency to your message. So now we go back to. So for FM, peak frequency deviation is related with your signal's amplitude, also the constant, the linear constant, like the slope, right? For PM, related with A, the same, right? KP is also the constant for FM signal, and also you omega m, right? Your signal's frequency. So we combine A and KP together, right? Delta omega, delta theta. This one is also modulation index. So for FM, and beta we call modulation index. So means from peak compared with your original signal's frequency, what is the ratio? So for PM, delta omega is theta times omega m. So we call theta or delta theta modulation index. Modulation index. So delta theta is modulation index for PM. Beta is modulation index for FM. So for PM, index is delta theta. This one is A times KP. Let's see if I have I remember we have an example for calculate bandwidth of PM signal. We can show the example, but not required for your homework or exam. This example is from our textbook 6.5.1. I'm going to go through with you, but for PM modulation bandwidth not required. But I want to show you one important thing. Using the definition of significant sideband. So we are going to show how to use significant sideband to calculate bandwidth in this example. Let me erase this part. Let's look at this one, read it together. Carrier is phase modulated by a sinusoid signal of 5 kHz. So my message frequency is 5K. FM is 5 kHz. And unit amplitude, so A is 1, right? So A is 1. And the peak phase deviation is one reading. So we know delta theta is 1 is 1. Now we want to calculate the bandwidth of the signal. What is my bandwidth? A, by using Carson's rule. B, use the definition of significant sideband. Okay, so we know Carson's rule, right? Carson's rule. B will be 2 times, right, delta F plus FM. Beta plus 1 plus FM. So we know FM. We know FM. 5. How about my beta? For PM. For PM signal, beta is your peak phase deviation. So beta is third theta is 1. 1 plus 1 times 5. I have 20. So my bandwidth by using Carson's rule is 20 kHz. Beta is 1, right? Definitely not narrow band. It's not very big, so we use Carson's rule. So this one almost the same as previous example. The only tricky thing is beta for PM is the same as your peak phase deviation. Okay, P I want to show you how to do it. No required, but it's a good method to know, right? It will give us most accurate bandwidth for FM and PM signal. So we want to use definition of significant sideband. Remember the definition of significant sideband is J N .01, right? 0.01. So any sideband's amplitude is higher than 0.01, we think that sideband is kind of obvious, right, or significant. Once J and beta less than 0.01, okay, that's too small. We are going to ignore those bands. So we have inequality, right? Higher than 0.01. Beta will be given, right? Here, beta is 1. So we know beta is 1. We know my threshold is 0.01. We try to figure out what is my N over here. Over here. So you look at your table. Beta is 1, right? Beta is 1. We look at over here. Okay. Carrier 0.77, so above threshold, right? First sideband 0.44, my amplitude is 0.44 above threshold. Second sideband 0.11 above threshold. The third one, 0.02. The first one is not listed here because it's too small. So we consider the sidebands 0, 1, 2, 3. They are significant sidebands, right? The last one is N. N equals 3. When N equals 4, will be too small. So bandwidth for significant sideband will 2N FM. 2 is right, 2 sides, right? FM means your signal's bandwidth N from this equation. So 2 times 3 times 5. We have 30 kilohertz. 30. This one we obtain the bandwidth directly from the spectral, right? So this one is more accurate than Carson's, but this one, Carson's rule is close. It's close. If you really want to get, the accurate